Hey everybody! In today's video we're going to figure out what is one definition rule in C++ and how the compiler can behave unpredictably in some situations that we will consider today. So one definition rule, or ODR, stands for the rule which states that a class, function or variable must have exactly one definition in a program. This rule helps prevent conflicts and ensures that the program behaves consistently. Speaking of compiler unpredictability, we're not just talking about a compiler error, we're talking about a violation that leads to undefined behavior. And the scariest part is that your program will still compile, it will still run, but it will be lying to you. We're going to look at a real-world example using inline functions, macros, and a simple logger. By the end of this video, you'll understand why this happens, and more importantly, how to fix it before it wrecks your project. First, a quick refresher. The one definition rule, or ODR, is a fundamental rule in C++. It says that across all your translation units, this is all your C++ files, any given function, variable or class can only have one definition. Or more preciously, if there are multiple definitions, they must be token for token identical. For regular functions, having two definitions will cause a linker error. The linker will yell at you and say, "Hey, I found the same function in two places. I don't know which one to use." You can see that kind of instance on your screen right now. But with inline functions, it's different. The compiler treats them specially. It expects that all definitions are the same, so it doesn't bother checking. It just picks one, and that's where the trap door opens. Okay, let's build a trap. Here's our innocent-looking header file, logger.h. We have a simple log debug functions. It's marked inline, and its behavior depends on a macro use logging. If the macro is defined, it prints message. If not, it's a no operation performed. Seems perfectly reasonable, right? Now let's create two models. First mod and the second one. They both include the header and call the logging function in a loop. Finally, a main C++ file that calls both of these functions. You can see it on the screen right now. Alright, let's compile this. Here's the critical part. We want logging for mod 1, but we don't want it for mod 2. So we're gonna write that for the first mod, we're going to declare use login macro, and for the second mod, we're not going to do that. Then we're going to compile main file, and then we're going to link everything together. Firstly we compile, then we link, and there's no errors, everything is good. So logically, what should happen when we run this? If our intention was correct, mod 1 should print logs and the second one should be silent. Let's run it. We're gonna say /result and boom! We're getting logs from the second mod. We explicitly compiled it without the macro, we never wanted it to print anything. Well, typically it is not a compiler bug, this is the ODR in action. Let's break down what just happened. Inside the object file of the first mod, the definition of log debug is one of the stdout statement. Inside the second one, the definition of log debug is an empty function. We have two different definitions of the same inline function. This is a direct violation of the one definition rule. The C++ standard says this is an undefined behavior. The compiler and linker are not required to diagnose this error. They are allowed to do anything. In practice, with G++ or GCC and many other compilers, the linker simply picks one definition, usually the first one it sees, and it uses it for the entire program. Because the linker picked up the debug version, every call to log debug, even the ones from mod 2, gets replaced with the printing version. Our intention was to disable logging for mod 2, but the program's behavior is now undefined, and in this case, it's simply lying to us. So, how do we solve this? How do we get deterministic behavior? Well, you have three main options. The first one, the header-only library trap, but I don't really recommend this. You could try to thwart the issue by making the function static inline. This gives each translation unit its own copy. But this can lead to code bloat, and well, it's just a hack. it doesn't fix the root cause, which is a macro changing the ABI of your function. Second option is to move to a source file. If you want to conditionally compile code, don't put the function body in the header. You can declare it in the header, but put the implementation in a .cpp file. Then the decision of whether to link against the login version or the no login version happens at link time in a deterministic way. But for this logger example, that might be overkill. And the third solution is about using modern C++ features to make the problem literally impossible. It's all about replacing the preprocessor with the compiler's type system. Let me show you how to handle it. We have already seen the problem. Macros and inline functions create an ODR time bomb. Let's walk through the new code that fixes this problem step by step and see exactly what happens when we build and run it. The first step is the policy type. First we replace the macro use logging with a proper C++ type, enum class log policy. It has two clear states, enable and disable. This is type safe. You can accidentally pass a number or a string by mistake. The second step is a template. Instead of a plain inline function, we now have a function template. The log policy is a template parameter. This is a crucial change. A template isn't a real function yet. It's a blueprint for creating functions. And the last magical step is using const expression if statement. And as you can see, it's not a normal if statement. It uses the keyword constant expression. The condition must be available at compile time, and it's because policy is now at compile time. Now, let's see how we use this new header in our model files. In the first mod, we call the template with the policy enabled. And in the second mod, we call the same template but with the disabled policy. You can notice the syntax log debug, log policy, enabled. We are not defining a macro, we are explicitly telling the compiler generate a version of our function where the policy is enabled and another where it's disabled. Now let's compile this. We don't need any flags for our compiler for now. The information is on the code itself. So we're going to say that we're compiling the login file, then we're going to compile first mod without any macro, and we're going to do the same thing with the second mod, and then we're compiling the main file. And after all, we're going to link them both together. We now have two different functions, log debug enabled and log debug disabled. They are as different as sinus and cosinus in mathematics. There is no ODR violation because they are uniquely named functions for now. When the linker runs, it sees in the first mod object file we need a function called log debug enabled, and in the second mod object file we see that it needs a function called log debug disabled. The linker is happy, there is no conflict. It puts both functions in the final library, but they are completely independent. Now, let's run the final program. And the output is exactly what we wanted. First model prints its logs. The second mod runs, but it's completely silent. But why? Because the function that runs in model 2 is empty version. The compiler literally compiled away the printing code. There is zero runtime overhead. So in conclusion part, I'm just gonna say that the ODR is one of those rules that seems simple until it bites you. Macros combined with the inline functions are a recipe for a specific kind of disaster, when your code compiles but behaves in a way you absolutely did not expect. And remember, if your code behaves differently depending on which C++ file it's in, you might have stumbled into ODR violation. And if you enjoyed this deep dive into the dark corners of C++, don't forget to like and subscribe. I make videos about C++, Qt framework, and computer vision to help you write better and safer code. Thanks for watching, and I'll see you in the next one.